Okay, so I'm back, and I fixed this thing real quick. I didn't have a wrong problem here. I wrote it down wrong. That was a 17 right there. So let's do it one more time. Again, I'll bring down the 1, multiply, 1, multiply, negative 12. 5 times negative 12 is negative 60. It does come out to 0. Okay, but it says what are the other factors, so now I have to take what's left over. Now remember, this started as an x cubed, so when I divided out the x minus 5, it's now x squared plus x minus 12. And so now I got to factor this x squared plus x minus 12 to find my other two factors. So x and 3 times 4 and positive and negative. So the other two factors are x minus 3 and x plus 4. So yep, it's a factor, and I can find the other ones. Number 19, it's a solve problem, and I notice it's cubic. So to solve a cubic problem, I'm going to hope there's a GCF, and there is. So now it's down to an x squared equation. Well, that's kind of right in funny here. Let's give it another shot here. So I'm going to take an x out, leave me with x squared minus 2x minus 3. So I've already found a solution, x equals 0, that x that I took out. I'm going to try to factor this guy. Maybe I won't have to use the quadratic formula. It doesn't need it, so x equals negative 1. That's what makes this 0. And x equals 3. That's what makes that 0. So I've got all three of my solutions. Number 20, what is the end behavior of this? So for this guy, I'm just going to graph him. And my calculator went dead. So I'll show you what he'll look like. And I don't care so much, the shape of it. We just need general idea. I know it's a parabola because it's x squared. And I know it opens upside down like this because of that negative lead coefficient. So on the right-hand side over here, as x goes to infinity, the function itself, f of x, it goes down to negative infinity. And over here on the left-hand side, as x goes this way, which is towards negative infinity, the function f of x goes also to negative infinity. So there's our left side and our right side. 21, compound interest. A equals P times 1 plus R over N to the NT, where A is the final amount, P is the principal, the starting amount, R is your rate as a percent, N is how many times the interest is applied per time period, and T is the number of time periods that are going to happen. Calculate the value of a deposit. So we got $1,000 principal, the starting amount. Compounded semi-annually, so 2 times a year, twice annually, for 8 years. All right, so our rate is 6%, 0.06. And how many times they're going to compound it during a year? They're doing it twice a year, so N is 2. And they're doing it for 8 years, so T is 8. And so it's really just trying to decipher this. So the amount you'll end up with is $1,000 times 1 plus 0.06 divided by N raised to the N 2 times T, so raised to the 16th power. So let's see if I can get my calculator turned back on here. Let's see here, we'll go back there, we'll choose the file. Sorry about this, the only way I can get it on my screen. There we go. So here I go, entering that to my calculator. 1,000 parentheses 1 plus 0.06 divided by 2 in parentheses, all raised to the, and I would just put 16 in here, or in parentheses 2 times 8. And there we go. Okay, so we'll end up with $1,604, and let's call it 71 cents. There we go. Just substitute into the formula. 22, half-life of caffeine in your body is about 5 hours. That means half the caffeine disappears after 5 hours. If you start with 120 milligrams of caffeine at 7 a.m., so 7 a.m., you get 120 milligrams. How many milligrams will be in your body at 10 p.m.? Let's see here. So that is a total of 7 to 7 p.m. That would be 12 hours. Then we got another 3 because we're going to 10. And so this is a total of 15 hours, and it cuts in half every 5 hours. So after the first 5 hours, you'd only have 60 milligrams. After the second 5 hours, you'd have 30 milligrams. And after the third 5 hours, so we get to 15 hours of time, you'd only have 15 milligrams left, and that's all you gotta do. That's how much would be left in your body. 23, how many complex solutions does this have? Well, it's a polynomial. Its highest degree is 3. So the answer is 3. 24, determine the expression for the area of a triangle. Area of a triangle is 1/2 base times height, with a base of x minus 5 and a height of 2x plus 1. So we'll just go ahead and multiply that out, and that'll be the area. Let's see here, 2x squared plus x minus 10x minus 5. So it's a half of 2x squared minus 9x minus 5. I think I'd probably express this answer like this. That whole polynomial, all divided by 2. That's the same thing as taking it times a half. So it's just applying a formula. Inverse functions. I talked about inverse functions on the part without a calculator. Inverse functions have this characteristic that they're all reflections about the line y equals x. And so if we had, for example, an exponential curve, a curve that goes up like this, its inverse would be a mirror image of it. And let's see here, it'd go right there about that line y equals x. And so it looks something like this. So they're reflections about the line y equals x, just a fact we want to know about inverse functions. What is that symbol called? This is the 4th root symbol. It means you need 4 of a kind to come out. Another radical problem here where we have to add. Here we don't get a calculator. That's 5 root 3. Let's see, 12 is 4 times 3, so a 2 comes out. And so we have a 5 root 3 plus 8 root 3. That gives us a total of 11 root 3s minus 3 root 5. And we're done. We got to distribute here. That's the square root of 18 minus 4 root 6. 18, though, is 9 times 2, so it's 3 root 2, because you can square root the 9 minus 4 root 6. Just like that. Number 29. 147, I think, is a prime number. I don't even know why I made the review guide. Hold it here. 147 is divisible by 3. 7 plus 4 is 11 plus 1 is 12, so I'm going to take it out of 3, and that is 49. 3 times 49, so a 7 comes out. X cubed is x squared times x, so you can square root that. So we square root the 49, square root the x squared, and inside we got the 3 and the x left over. Number 30, I think I would do this. That root 6 over 24, I'm going to write this 3 a little bit better. I'm just going to trap those underneath the same radical. So 6 over 24 just simplifies to 1/4, and that's just 1 over 2. So this is 3 times 1 over 2, which is 3 over 2. Just like that. Let's see here. In the equation, what values of x must be excluded? See, this equation here is a big fraction. When they're asking what needs to be excluded, they're talking about what things could cause your denominator to become 0, because we can't divide by 0. So x plus 4, we can't have x equal to negative 4, because negative 4 plus 4 is 0, and you're dividing by 0 then. The other one, 2x minus 1, what makes him 0? Divide by 2. So x can't equal negative 4 or a half, because that's what that solves to. Okay, so that's just what we throw out. Those could not be answers to this equation, because if they do, you end up with a denominator of 0, which is impossible. List all the possible rational roots. Remember, that's our p and q stuff. So p is plus or minus 1, 2, 3, and 6, the factors of 6. Q is the factors of 2. And so our rational solutions are all the p's over q's, the possible. So we go 1 over 1, we go 1 over 2. We go 2 over 1, we go 2 over 2, but that's still 1. Already got it. We go 3 over 1, 3 over 2, 6 over 1, and 6 over 2, which is 3, so we don't have to put it in. See here, find all the zeros of that one. So what I'm going to do is what you should do. If you're ever asked just to find the zeros of a function, graph it and look at them. Remember, these are also x-intercepts. So all I'm going to do is look at the graph and find the x-intercepts. So I'm going to graph this thing real quick. 2x cubed minus 7x squared plus 9. Zoom 6 it. Hopefully the solutions show up right there. So I'm going to zoom in here a little bit. It looks like negative 1's a solution. So I'm going to hit trace, type in negative 1, hit enter, and it told me one of my zeros is negative 1. Looks like another one is 1.5. I'm just counting on my screen. So I'm going to type in 1.5. Yeah, that's one of them. 1.5 is a solution, or 3 over 2. Same thing as 1.5. The last one looks like the number 2, so I'm going to hit 2. No, it is not. 1, 2, oh, it looks like 3. Yep, it's 3. Here's my 3 answers. Negative 1, 1.5, and 3. I mean, you could go crazy here and try to factor that thing, but I don't know why you'd bother. State the domain of this guy. Domain, remember, is what x values are. And so I'm going to graph him really quickly. Just take a look here. Second square root of x minus 5. My dog would like to come in and learn math, if you can hear. I'll zoom 6 it. Well, boy, if you look at that graph, you can see it starts when x is 1, 2, 3, 4. Oops, 1, 2, 3, 4. Looks like when it's moved over there, 5. In fact, if you look at the stuff under the radical, that stuff has to be positive or 0 at the smallest, because you can't square root negatives. So if you just set that thing greater than or equal to 0, you find out the domain. X has to be greater than or equal to 5. And you can actually see that on the graph. It starts when x is 5, and then as you plug in those values, you start to get y values out. What is the domain of this function? Not sure why we got it in there twice, but we must have a similar question about it on the test. So the same thing. Let's go, hey, x plus 3. What makes you greater than 0 or equal to it? So x has to be bigger than negative 3. That's it. Not very challenging to find domains of these radical functions. All right, next page here if we can. There we go. 36. Let's graph that guy. We'll throw him onto the old calculator here so you can see what he looks like. So second square root, x plus 4, arrow out there, plus 5.